Good afternoon, I'm Mr. H. Thank you for joining me for this video where we are learning how to assess the strength of weak bases, but these are your organic weak bases, compounds made of nitrogen and or carbon. Do not confuse these for your mineral strong bases such as lithium hydroxide or sodium hydroxide, potassium hydroxide. You can even talk about barium hydroxide, strontium hydroxide, calcium hydroxide. These are all your strong bases which are based on minerals. When we are talking about weak bases, our representative base is this NH3, ammonia. Ammonia serves as a good reference for assessing and judging the strength of your weak base. If you have an aqueous ammonia and you put it in water, which is liquid, you are not going to fully hydrolyze it or ionize it, hence the double arrows. You will generate the conjugate acid, which will be your ammonium ion, and the hydroxide anion, which are aqueous. You can do all of this without looking at Kb and equilibrium expressions. Your clue and your tip is to look at this and to look at the strength of this. You have a base, a weak base, giving rise to a conjugate acid. If your conjugate acid is stable, it is coming from a strong base. And by strong base, I'm talking about strong organic base, which is still weak compared to your mineral bases. These are still all weak bases, but it's relatively stronger. If your conjugate acid is less stable, then it's coming from a weak base or an organic base which was relatively weak. We'll say WOB, weak organic base. That's what you want to remember here in terms of your tip. Conjugate acids which are relatively strong are less stable. Conjugate acids which are relatively weak are more stable, but it's the opposite effect with regards to the base they're coming from. How can we sum it all up? You can do this. A weak base, which gives you a conjugate acid that's stable but less acidic. This right here will be stronger weak base. A weak base, which is giving you a conjugate acid that's less stable but it's more acidic. Then this right here is coming from a weak base, an organic weak base, which was relatively weak. Remember that. A conjugate acid which is stable and it's less acidic is coming from a relatively strong organic weak base. A conjugate acid which is relatively less stable but it's more acidic is coming from a weak, relatively weak organic base. That's the rule which will drive everything forward. Now that we've talked about this rule, let's look at our representative comparisons. How can we do the comparisons? Everything is based on this ammonia molecule. You know, NH3 looks something like this. If you start substituting these hydrogen groups with methyl groups, CH3, you're looking here at methyl groups. Then you can make these things stronger weak bases. They're organic bases, but they'll become stronger. And you can start substituting these methyl groups in places of this and this and this, and you'll slowly make this weak base relatively more strong. What's the next representative reaction? You're looking here at nitrogen, you have a hydrogen, hydrogen, and now you've squeezed in a methyl group. Now, when you put this in the water, we're not putting the aqueous liquid and all of that. We'll just keep everything as is. We are looking at this. We've created the methyl ammonium ion and the hydroxide anion. This right here is the conjugate acid of this weak base, methylamine. Methylamine. This is a stronger base than ammonia. Its conjugate acid is more stable, but it will be less acidic. This is more acidic, but it's less stable. This is less acidic, but it's more stable. Remember, if it's less acidic but more stable, the conjugate acid is coming from a relatively stronger weak base. Your next addition is of another methyl group in place of another hydrogen. You see how I've got two dimethylamine, methylamine. These are my compounds. And I put it in the presence of water. Now I'm creating here dimethyl ammonium ion. That's what I have, plus hydroxide. This right here is even more stable and it's even less acidic. This conjugate acid is even more stable, less acidic, but it's coming from a stronger, relatively weak organic base. Your last modification would be to bring in another methyl group in place of this last hydrogen, and you've generated trimethylamine. Trimethylamine will be the strongest of all of these weak bases because its conjugate acid will be the most stable, but it will be the least acidic. And you can imagine why that would be the case. Because all of these methyl carbon groups are making this conjugate acid less acidic and they're driving it towards more basic character. Trimethyl ammonium ion, trimethylamine. All of these are still Lewis bases, but that's irrelevant here. They all have a lone pair of electrons on the nitrogen, but you are looking here now at an increasing trend of base strength. This is the weakest, this is the strongest. The strongest here at this end, the weakest over here. In terms of your conjugate acid, this is the strongest conjugate acid, so your conjugate acid strength is up this way. The weakest conjugate acid, the strongest conjugate acid, your ammonium. So by substituting these methyl groups in places of these hydrogens of ammonia, you're generating more basic compounds which are organic weak bases, but they're stronger, but their conjugate acids are more stable, but they're weaker acids. These methyl groups help to stabilize this electron deficiency, which is represented by the positive sign over here. But they end up making this conjugate acid less acidic. So what is your rule you want to end up with here? A stronger conjugate acid is less stable, but it's coming from a weak organic base. A very less acidic conjugate acid, which is relatively quite stable, is coming from a relatively stronger organic weak base. These are all weak bases, but these are more strong, and this right is more weak. By replacing the hydrogens with these methyl groups, you're doing that exact effect. You're making your weak base more strong, but you're making your conjugate acid less acidic, but you're making it more stable. So remember what you've seen here in this video, and that'll be the end of it. Thank you for watching.